laptop. So if your laptop can handle it now, well and good. Okay.
Yeah.
Cool. Um, the first remove duplicates. So there are two methods. The first one is this one, define delete duplicates, which I did. Um, this thing over here is called a doc string. So what a doc string does is, I try to include it in all functions whichever I define. The point of doc string is to like define, like write a short note as to what the function is and what its parameters and what it returns. So I defined a new list, correct list. Then for I in main list, so going through each element of the main list, if it is not there in correct list, I append it. If it is there, I just like I don't have anything for that, and then I return the correct list. So this is what I did. If you guys have any better method, well and good. The second method which I used was new list is equal to list of set of test underscore list. So set takes out all the duplicate values, but the thing is, I think it returns it as a this thing. What? Once again, set. I think it returns it as a tuple or something. I don't know. I have to see the class set of test type. I just want to see the class once. Yeah, so it's a set type. It's called set type. Okay, so what it does is it deletes all the duplicates already, and it's in set. Then I convert it into list using the list function. So this is
Macha, first
the
can you say it again? First method.
okay. So the first method, basically I define an empty list, bro. I initialize a empty list which I'm going to return. Then what happens is for I in main list, which means it's iterating through each element of main list. So this is our main list right now, the test list. So it's going through two. I will be first two. Then in the second loop it will be two. Then third loop 34, fourth loop 15, fifth loop 33, and so on. So if I is not so correct list is empty right now. Okay, so it doesn't have anything. So what happens is, in the first loop, the I is taking the value 2.
Okay.
I
You are just
is not,
copying
that's
which
what,
is not in the main loop,
which is not
main
there
list.
in the
Sorry.
new list. No, which is not there in the new list from the main list. So now I
sorry,
is 2. First, in the first loop, I is not there, 2 is not there. But then when we go again to the second loop and I is again 2, it is already there in correct list. So it doesn't execute this statement. And the reason why I'm not putting correct list of I, so many, like I've done this mistake many times and it stuck to me, correct list of I equal to, I put like main list of I, but that doesn't happen, dude. Like that doesn't work out properly because you can't like add an element to an empty list. Okay, you have to append it to the list because the list shape is not defined right now. But when you append it, it just adds the element into the list. I'm not sure whether that's a good explanation, but yeah, that's what happens. Then for matrix addition, I've defined two matrices. I've made them square matrices, but so these are two-dimensional matrices. A two-dimensional matrix, which is normal, which is not any other kind of matrix, is a matrix which is a list of lists. So this is a list of 3 lists with each list having 3 elements. So A is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. B is equal to 11, 12, 13, 14. Also, another thing I forgot to tell. So you see this doc string over here, right? I've written it over here. Generally, if I write a Py script and then I have all of these doc strings, when I call the function, if I press Shift Tab, it gives this. Okay, so Jupyter on its own understands that this is called the doc string, and in the doc string it says the same thing, except the list main list returns a new list after removing the first occurrences of duplicates. The parameters are main list, the list whose duplicates must be removed, and it returns correct list where first occurrence of duplicates from main list are removed. I made sure to say the first occurrence of duplicates are removed. Okay, and that's the same thing that's written over here. I always write it so that it's better to understand in case I call it somewhere in the future. So coming to matrix addition, this one accepts 2 matrices of equal dimension and returns a matrix which is the result of addition of both matrices. The parameters are matrix A and matrix B, which are both 2-dimensional lists, and returns result, which is a 2-dimensional list, which is sum of matrix A and B. The first thing I do is to check whether if matrix A and matrix B are compatible for addition, which means checking the number of rows is equal to the number of rows of A and B, or number of columns equals number of
Hmm.
columns of A and B. So that's what happens over here. If len of matrix
So
and over here,
why do you put matrix of A of 0 in that if condition?
so the I'll let you just one thing. I'll get to that. First thing we're assuming is this person has given a matrix which by itself is a proper matrix. Like it is not 2, 3, 4, 5, 6, 7, and 8, 9. Okay, so that is one assumption we're already making. The fact that he has defined the matrix correctly is one assumption we're making. Okay, we can try to put that also over here if you want, but it's just a long piece of code. Okay, so len of matrix A of 0. So when you look at this matrix, you can immediately understand that 2, 5, 8, 3, 6, 9, and 4, 7, 10 are the columns, okay, are basically the columns. Now, if I put A of 0 and I print it, it gives 2, 3, 4, okay? So that gives us the number of like elements which are over here, like it gives 2, 3, and 4, okay?
Oh, okay. The
If you
first row
count
itself
A
is a
of
single list.
yeah, so if you count A of 0 alone, then you will get like the number of columns
I
on
got
this.
it. I got it.
Okay. So even if you can take A of 0 or A of 1 or A of 2 also, but if you count A of 0, it basically gives you the number of columns. Okay. Similarly for B of
Hey,
0, I just want to check if the
why
number.
is it columns, Ra? Shouldn't it be rows?
No, both I'm checking. See, first I'm checking len of matrix of 0, like the whether if the
Okay.
columns are equal and whether if the rows are equal. So the len of matrix of A alone, why am I taking? Because this is a list of lists, okay? That means this is one element, this is one element of the list, and this is one element of the list. If I do over here len of test underscore list, I'll get 12, which means there are 12 elements over here. Now, if I try to find len, so each one of these lists which are inside over here are already another list, okay? So all I need to do is just count the number of elements in A to find the number of rows. Did you guys get it, or should I like go through it once more slowly?
Yes, sir, we got it.
Okay.
Got it. I
Okay.
got it.
Yeah. So basically, if I just count the number of elements in A and number of elements in B, I'll get the number of rows. Similarly, if I count the number of elements in one of the lists of A, I'll get the number of columns. And the same thing for B, okay? So over here, matrix of 0 is not, if the number of columns in A is not equal to the number of columns of B, or if the number of rows in A is not equal to number of B, I'll print please enter two matrices with equal dimensions.
This
And
is
I'll
if it is a
exit the
square
function.
matrix, right?
No, it doesn't need to be a square matrix. For example, I'll do it right now if you want. Like I can just change it again. So, okay. The thing is, these two should match always. No, this is not a square
Oh
matrix. Okay?
yeah. I get it.
Now you understood, right? Like
Yeah.
these two need to match. The number of rows and number of columns for both of these need to match. That's all. Okay.
Yeah.
Okay. So, so that's what it is. I defined a square matrix because it's easier and it looks nice. And forgive my OCD. But yeah, coming to this. So please enter two matrices of equal dimensions and exit. I put keep kernel equal to true because if I exit without that, I don't know why it gives me a dead kernel. I tried to search on Stack Overflow. I didn't get a proper answer. But yeah, if I exit with keep kernel equal to true, then well, and then what happens is it exits this function completely. It doesn't execute the rest of the code. Okay. Now that
So
it
keep kernel
exited,
is like a break, is it?
yeah, it's basically like break. In a for loop, if you put break, it exits the for loop.
Yeah.
But if you put exit for a function, it exits the function. Okay. So now that it exited, it didn't exit. It came to this line means then it's satisfied. These two are compatible. Okay. I have used something called list comprehension. Okay. So list comprehension is okay, you can do matrix addition in the traditional way, okay, with for I in range of length of the matrix A, then do another for loop and then like do for loop. What is that? Nested loops. Yeah, you can do nested loops. But I did list comprehension because it's more. So what list comprehension is within one line. Some programming languages like Python, they provide you with syntax and also with functionality such that you can get a full list by defining it within one line itself. Okay, I'll give you a small example. X is equal to 0 for I in range of 3. Can you, like, you guys can understand what happens, right? It will give 0 for I in range 3, which means for till 3, till I counts till 3, X will have the value 0. So if I print X, it will give me a list of 3 zeros. Okay, you guys get what list comprehension means?
Yeah, got it.
Yeah.
It's kind
So
of like dynamic, a dynamic equivalent, right?
yeah, exactly that. It's a little, I don't know whether if it's faster or not. I haven't tested it out, but I find it much more comprehensible than a for loop. Even the for loops are a little like basic and like they're better to learn from. I feel like list comprehensions are more comprehensible and more concise. Okay, so what I'm doing over here is, so this, we need to get a nested list. Okay, we need to get a nested list. So in the same example as before, if I did X equal to, and I put two lists over here, 0 for I in range of 3, for J in range of 4, what you can guess will happen is this list will have 3 zeros and this list will be repeated 4 times because it's looped as J.
It'll give like a matrix.
It will become a matrix. So if I print X now, it will be a matrix of 3, 4. I mean, 3, 4 number of, no, it will be 4, 3. Okay, because this elements inside the small list is the number of columns, and the number of lists which are there outside is the number of rows. That's what we saw over here, right? The number of elements inside the small list is the number of columns, and the number of lists we have are the number of rows. So if you look at the matrix now, I'm sure it is going to be 4, 3. So it'll have 4 rows and 3 columns. Yeah, there it is. So four lists with 3 columns. It's obviously not printed that well, but you guys get the idea. Okay, if you want to print it properly, for I in X, print I think it will look better. Yeah, so this is a 4, 3 matrix. Okay, so the outside loop lets us define the rows, and the inside loop lets us define the columns. Okay, that's what happens in a nested loop also. The outermost wala is used for rows and the innermost wala is used for columns, so that you can go through each matrix. So I'm adding matrix A of I comma j plus matrix of B of ij for j in range of matrix A of 0. So what's happening over here is, we know that this is the number of columns. So till each column goes, till it goes through each column, I'm trying to add matrix A and matrix B. And this is happening for every row of matrix A. So if we look at this, what's happening here is, just give me one sec. Yeah, so what's happening over here is, matrix, let's go from outside to inside. Okay, for I in range of length of matrix A. So length of matrix A is 3. That means it's going through, let's say, A of 0. Okay, it's going through 0 now. Okay, now I will be first 0. Okay, length of matrix A is 3. I will be 0. So I value is 0 for both of these now. Okay, now let's go to J. Okay, so the first loop I is happening at 0. Now that's fixed. Okay, now we need to go through every loop of J. J in range of matrix A of 0. That means it's going from 0, 1, 2. Okay, so matrix A of 0, 1, 0, 0 plus matrix B of 0, 0 is the first element. Then the second element will be matrix A of 0, 1 plus matrix B of 0, 1. Then it will be matrix A of 0, 2 plus matrix B of 0, 2. That will give us the first list over here. Following that, it will go to the next loop, I equal to 1. Okay, then you'll have matrix 1, 0, B 1, 0 added. Then the next element will be 1, 1, B 1, 1, 1, 2, B 1, 2. Then I will go to the next number 2, 2, 0, 2, 0, 2, 1, 2, 1, 2, 2. Okay, then I print out the resultant matrix and then I do matrix addition. Okay, So as you can see, it gives the same thing: 2 plus 11, 3 plus 12, 4 plus 13. It gives you 13, 15, 17, 19, 21, 23. I'll run it again right now. Shift enter. Yeah, it's given the correct one. Okay. Now another method which you can use, I don't know, like I didn't know whether if we were supposed to use this conventional one or whether if we can just use this, is use Numpy. So Numpy is a mathematical library developed for Python. The reason people use Numpy is because it's written in C. So Python by itself is really slow. So you know how C++ is very tough to code and like the syntax is a little tough, but that's because the more tougher the syntax is, the easier it is for the computer to understand immediately. Over here though, writing if len of matrix say all of that, the computer needs to go through all of this, learn this language, and then convert it into 0, ones and everything. So it takes a lot of time compared to C or C++. So Numpy is a package which is installed as soon as you install Anaconda, is a package which is written in C. And Python is a glue language. A glue language is a language which, so Python is a kind of glue language. I don't know how to define it properly. It basically calls functions in itself. Dude, I hope I don't screw it up. One second. Glue language meaning this. Glue language is a programming language that is. I'm sharing this tab. Yeah. Glue language refers to a programming language that is designed specifically to write and manage program and code, which connects together different software components. So Python over here, it uses Numpy and it connects you to C++. Okay, so that's what Numpy is, and it's super fast compared to all of this list comprehension and everything because it's running it on C++. And we do Numpy as NP because NP is an alias. This is called an alias, and the reason we use aliases is because if we want to like use np.add like 15 times in our code, we don't want to type numpy. I can even import numpy as gv, and then I can write gv.add. But the naming convention which many people follow is Numpy as NP. Same as how we have pandas as PD and so on. Matplotlib.pyplot as PLT, like that. So this is np.add, which is a Numpy function for adding two matrices, and it returns an array, which is just a single line of code. We don't need to write all of this. So this is another method which you can use. Coming to matrix multiplication, it's a little like this thing. So it's a little tough to understand. Like, I found it a little like, when we first learned it in first semester, it was tough to understand, but now it's fine, I guess. So it accepts two matrices of equal dimensions, as in compatible dimensions it should be, and returns a matrix which is the vector multiple of both of these matrices. Okay, so the parameters are matrix A and matrix B, and result is a two-dimensional list, which is a vector multiplication of A and B. Now we have to first, like I tried to define it first, okay, the resultant matrix. As I said over here, you can't just put correct list of I is equal to main list. Over here also, I could do result dot append of this value, but then I found it really tough, and I just thought like defining a list will be much easier. So result equal to 0 for I in range of length of matrix A, for J in range of length of matrix B of 0. You guys understand why I did this line of code? Fam, are you guys here or are you guys asleep?
Yeah.
Okay, so I'm sorry if I'm going super fast. I'm really sorry. The thing is over here, as you can see, this correct list, I've defined it as an empty list, okay? Which is why I can't put correct list of I is equal to main list of I, or correct list of 0 equal to main list of 0 or something like that. Okay, because I don't know the shape of the list, and hence I don't think Python allows you to add elements like that, because you just can't replace anything. There's nothing inside. But when you append it, it just adds it, attaches it to the list. Okay. I could have done the same thing over here in result. Over here, like this is the last step where I form each element of the result. I can put result dot append of this thing, but I find it tedious. I just wanted to do the normal maths which we do. So I already defined my resultant matrix with all the elements. So for example, over here, if my corrected list was 0, 0, 0, 0, and it had all of the values of length of this matrix. So this is 1, 2, 3, 4, 5, 6, 7, 8. If I had correct list of 8 zeros, then when I append it, then I don't need to append it. I can just do correct list of I is equal to, or correct list of 0 equal to that, correct list of 1 equal to that. And that way I can change and manipulate the list, okay? So that's what happened. That's what you can do, okay? You can manipulate a list when it's already defined and the shape is already there. So, which is why I've done that over here in the result matrix. I've defined a resultant matrix which will have the shape of the vector multiplication of A and B. Do you guys know what the shape of a vector multiplication will be? If matrix A is M cross N and matrix B, dude, I don't know whether if I admitted him. Yeah, okay. So if matrix A is M cross N and matrix B is N cross P, then you know that the resultant matrix will have the shape of M cross P. Okay. So what happens over here is I'm just defining the so M cross P means you guys saw over here. If I wanted a 4 cross 3 matrix, the outside one needed to have 4, the inside one needed to have 3, and that's what I did over here. Okay. I created a matrix with len of matrix of A, which will give us the number of rows, and it'll give 0, 0, 0 for that. And for j and range of length of matrix of 0 will give us the number of columns. So it will repeat that and give us a resultant matrix, which is the one which is compatible. So over here, if you see, this is the matrix which we're going to use. It's 2 cross 3 over here and 3 cross 2. Len of matrix A will be 2 over here. The resultant matrix should have 2 cross 2, right? If you multiply A and B over here, it will be 2 cross 2. So len of matrix A has 2 elements, 2, 3, 4, and 5, 7, 8. These two are 2 lists, so 2 elements. So that's why the number of the number of columns will be 2. And then for j and range of length of matrix, you know what? This is wrong actually. Thank God I saw this. It should be the number of rows. Wait, M cross N will be no, I'm correct only. Yeah. So yeah, this will give us the number of rows correctly, and j and range of matrix B of 0, which B of 0 is 11, 12. That's 2 elements, so it gives us 2. So it gives us the 2 cross 2 matrix right now for result. Now we're checking if the matrices are compatible or not. If the length of matrix A of 0 is not equal to the length of matrix A.
What does length of matrix A give you?
Length of matrix A gives us the number of rows.
And matrix, if it says A of 0, it's column, right?
Yeah, A of 0 means column, and the other way around. Okay. So what we're doing over here is we're checking if the number of columns of matrix A is equal to number of rows of matrix B, which is the basic rule which we do, right, when we check for matrix multiplication. So if it is not equal to that, then I exit. I give an exit statement and then I exit, or else I do this entire iteration. We've done this, and I'll go through this go through this superficially. So what we're doing is we're first going through the rows of matrix A, then we're going through the number of columns in matrix B, then we're going through the number of rows in matrix B. Okay. The reason we're doing this is because we want the number of rows. So I and J in the end should fill like the number of rows of matrix A and the number of columns of matrix B. So in the end, I and J will have to satisfy these two mainly. We use K over here to go through like each element and then multiply it with the corresponding element in matrix B. I'm really sorry if I'm not explaining it correctly. Like this is
got it. It's similar to C++, right?
Yeah, it's similar to every code. Yeah, exactly. We use the same code everywhere, dude. It's not different anywhere.
Yeah.
Yes, we know that algorithm.
So this algorithm, obviously, all of us know it. Yeah, we already know matrix multiplication algorithm. Then for I in result, I just print I. So if I shift enter this and I shift enter this, it gives me the matrix multiplication. Same as matrix addition, we have for Numpy also, we have np dot matrix multiplication, matmul, or you can use, I'm just going to check if dot works. Yeah, so np dot dot will give us a multiplication of both of these matrices. It gives us the same result. It's a one-line code. Now we have union of lists. So what union of lists is, it takes all the elements of both lists and deletes the ones which are repeating. Okay, so what I did is, this is like, I think the correct method, final list is equal to list of, so what set dot union does is, it takes both of these lists, combines them, and when you do set of this union, as we discussed before, it deletes all the duplicates. Then that set class data type is converted into a list. That is our final list. Okay, so set dot union just matches both of these lists together and then deletes the duplicates. Then the set dot union of list 1 2 will give us actually a set data type. When I put list of that set data type, it converts it into a list and it gives us a final list. Okay, so if I take 1 2 3 4 5 6 and 2 8 3 5 10 11 12, it's going to give us 1 2 3 4 5 6 8 10 11 12. It's deleted at the extra 2, the extra 3, the extra 5. Okay, the another thing we can do is just add these two lists. When you do list 1 plus list 2, it will give you 1 2 3 4 5 6 2 8 3 5 10 11 12. Okay, then remember the function which we did in the beginning, which is delete duplicates. That's what I did over here. I just deleted the duplicates. So isn't that what union is? You just add both the lists and see what is intersecting, which is the duplicates. So that's what I did. But you know what, that's actually what I did. Another, I don't know whether if this is right or wrong, because if you have 2, 2 over here, it might screw up over here. So I would not recommend this at all. Okay, I would not recommend this. Okay, so another thing which we can do over here, the next one after union is intersection, and this I've done again with list comprehension. So there is I for I in list 1 only if that value is there in list 2. Okay, so we're going through list 1, and so this is the loop. Okay, this is the loop, and this is the value the list is going to take. So the loop is that for value in list 1, so it's going through all the elements of list 1, and the condition is that if that value is there in list 2, then list 3 will take the value. Okay, so I'm returning list 3. I don't even see I didn't try to test it also. I'm like kind of sure that it'll work, but if you guys want to test it, go for it. I hope I'm not going too fast or anything, guys. But yeah, then defining concatenate lists. Okay, so that is the last program which is given, which is concatenating lists. We just need to she said 2 lists are only being concatenated in the mail. So you have to take 2 lists and check whether if you can concatenate them. That's why it's always going to be 2 lists. So I'm just checking whether if both their lengths are equal, because if lengths are not equal, we can't do Raj, CSC, Kumar, Mech, Sheila, Tripoli. So I just check if the lengths are equal, or else I go to the resultant list is equal to 0. So I define the resultant list now. Okay, this is the resultant list, same how I did over here in matrix multiplication, trying to define the resultant mix. And what list I'm doing it over here. So I'm giving it the value of 0 for range 2, because each element has 2 values for I in range of length of list 1. Oh shit. So for I in range of length of list 1. So what that does is it gives 0, 0. If I just print resultant list after this step, okay, it'll give 0, 0, like as many times as list 1 order length. Okay, so if we have like Kumar, Sheila, and Srinath, and we have something like Srinath, BMA. Okay, now what will happen is over here till now it was length of list 1 was 3 till now, but I've changed it to 4, and both of these lengths are equal, so it doesn't matter. Okay, we check whether if they're equal. So it doesn't matter if I put list 1 or list 2. It'll just check for the length, and then it will create it will create a matrix for that. If you want, let me just I don't know how to control this. Yeah, control that. Okay. Let me just take out this one comment, and then if we print resultant list, expected indent. Oh, yeah. So if I just print the resultant list now, it will give us 4 elements with 0, 0, 0, 0, 0, 0. Okay. Uh, but what I've done over here is, you guys know what's happening over here. I basically, sorry guys, we need to indent this properly or else it won't work out. Cool. So for I in range of length of list, the resultant list of I of 0 is list of 1, 1. So what this does is I of 0. So when the value is, we're in this element now, we're in this element, I of 0, that means the first element of the first list will take the value from, will take the corresponding value from the first list, and the second value of this list will take the corresponding value of the second list. Then I just print the resultant list, and if you run it now, okay, indentation error, okay. If I print the resultant list, I think this is what ma'am wanted. So yeah, that's what. I guess that's all, guys. There's one more experiment called dictionary manipulation. I'll just text ma'am in the group as to what it is. But yeah.
Okay, da.
Okay. Thanks a lot, guys. If you guys have any